this video we'll be discussing section 4.5 from chapter 4 of P3, and I'm discussing how to use the compound angle formulae in reverse to solve certain equations. So let's consider an example. Okay, let's say that we have sine of x, okay, 6 sine of x plus 7 cos of x is equal to 0. Okay, if you can easily solve this equation, okay, without having to worry about any compound angle formulae, because we have a 0 on this side. Okay, notice that if we have, since you have a 0, we can easily take the 7 cos x to that side. Okay, this becomes 6 sine x is equal to minus 7 cos x. Divide both sides by cos x. Okay, so this side if we divide by cos x, it cancels out. This side if we divide by cos x, it simplifies to tan x. Okay, and therefore this becomes tan x is equal to minus 7 by 6, and you continue solving from there. Now instead, let's say that instead of this, okay, we are given 6 sine x plus 7 cos x is equal to 5. Okay, 6 sine x plus 7 cos x is equal to 5. Okay, in this case we actually cannot use the same method that we used in the previous case. Okay, you cannot simply take 7 cos x to the other side, because if you take 7 cos x to the other side and divide all sides by cos x, you'll end up with 6 tan x is equal to 5 by cos x minus 7. So we have still not been able to get rid of this, the fact that we have two trigonometric ratios in our equation. Okay, so this is definitely not possible to be solved in this manner. Okay, usually what we'll be doing is that if we have a complex, if we have this combination, okay, sum or difference of two different sine and cos, okay, a sum or a difference of a sine and a cos ratio, we will try to combine them up into a single trigonometric ratio. In other words, if you have sine and cos, you will try to combine them up into either r into sine of something, okay, and we're not going to do anything on the right hand side. So in other words, you're going to combine this into a single sine ratio or a single cos ratio. Okay, what is inside is going to be different, so it could be x plus minus something, some alpha, or x plus minus alpha for the cos ratio. Okay, so in this case, till now, or in all the previous videos, in all the previous sections, you were expanding, okay, the double angle formula, okay, to make our work easier. In this case, we are doing the reverse procedure, and you're going to combine two sine and cos ratios into a single sine and cos ratio, so that we can it makes our solution, our working easier. Okay, so before we try to solve those kind of equations, first let's discuss how exactly you're going to convert this sum or difference into a single sine ratio. Okay, so if we have r sine of x plus minus alpha, if you want to use this form, okay, let's discuss r of sine plus minus sine of x plus minus alpha. If you expand this equation, you get r of sine x plus minus alpha, you get r sine x sine alpha plus minus r cos x cos alpha. Okay, the r is simply a coefficient that just gets multiplied to both of them. So you have r into sine x, sine x cos alpha, and r into cos x sine alpha. Okay, so sine x cos alpha plus minus cos x sine alpha is basically your compound angle formula for the sine ratio. Over here, the r just gets multiplied to both of them. Now, okay, once you get this, okay, the first step, if you want to use this form, is to expand it, okay, and then compare it to what you have. Okay, so in this case, you have 6 sine x plus 7 cos x. Okay, we have 6 sine x plus 7 cos x. Okay, notice we have 6 sine x plus 7 cos x. Okay, and then compare each of the coefficients separately. So for the sine x, we have sine x. Okay, the 6 is therefore going to be equal to r cos alpha. Okay, so r cos alpha equals 6, and then r sine alpha for the second one, r sine alpha is going to be equal to 7. Okay, and since you have plus over here, we're going to use only the plus version. Notice we are just using the plus version for this formula, okay, because the plus is what you have in our final answer. R is positive, okay, just to make sure R is always positive, okay, R is positive, okay, and your alpha is going to be acute. In other words, 0 is less than alpha, which is less than 90 degrees, okay, 0 is less than alpha, which is less than 90 degrees, okay, or pi by 2 if you're having radians, okay. So we have R cos alpha equals 6, R sine alpha equals 7, okay, and the plus is simply plus, therefore we are not using the minus version of this formula, R sine of x plus alpha, we're not using the minus version. So you have R cos alpha equals 6, R sine alpha equals 7, and now you need to solve these equations, these two simultaneous equations, to find the value for both R and alpha. Notice you have two unknown variables and two equations, okay, so we have one equation here and one equation here. The first step we're going to do is divide the second equation with the first equation. So divide R sine alpha by R cos alpha. R sine alpha is equal to 7, R cos alpha is equal to 6, R cancels out, sine alpha, tan, cos alpha cancels out to give you tan alpha. So tan alpha is equal to 7 by 6. From that you can calculate what alpha is. Okay, alpha needs to be acute. Just to repeat it, what he said before, alpha is going to be acute. Okay, so this is how you find alpha. You can substitute alpha back, you can substitute the value that you find for alpha back into either equation 2 or equation 1 to find the answer for R. But usually you do not do it that way. What you do is we do a second we write down this expression, we use the identity R of R cos alpha the whole square plus R sine alpha the whole square, okay, R cos alpha the whole square plus R sine alpha the whole square. This is going to be equal to 6 square plus 7 square, okay, and notice if I expand this, we get R square into cos square alpha plus R square into sine square alpha, okay, and that you can factorize it out, you can factorize R square out, you get cos square alpha plus sine square alpha, and notice that cos square alpha plus sine square alpha is equal to 1. Cos square alpha plus sine square alpha is equal to 1. In other words, this is R square, and R square is equal to 6 square plus 7 square on the right hand side, and from there you can find out what R is. Okay, so you get what R is, you get what alpha is, and we can replace them into this expression, and let's use the calculator and find the answer. Okay, for the first one we have alpha is equal to tan inverse of 7 by 6, and that is equal to 49.4 degrees. We're just using one answer, we just need the acute angle, we just need one value for the angle. For R we have 6 square plus 7 square the whole root, and that is equal to root 85. Okay, substitute this back into this expression, and therefore we can get that, okay, 6 sin x plus 7 cos x, 6 sin x plus 7 cos x is equal to root 85 into sine of x plus 49.4 degrees. Okay, so overall finally we have successfully converted this sum of two distinct trigonometric ratios, where trigonometric ratios are sine and cos, into a single sine and cosine ratio. Okay, R is root of 85 and this is 49.4 degrees, which is our alpha value. Okay, now this is one way that you can work out. Okay, we could convert it into either a sine ratio, we can also convert it into a cosine ratio. So let's try to work out the cosine ratio. Okay, so if we try to work out the cosine ratio, we see that we have, let's try to use R cos of x plus alpha. So if R cos of x plus alpha is equal to R cos x cos alpha minus, okay, notice that for the plus you have a minus, okay, plus in the cosine is going to be a minus in the expansion. That is going to be r sine x sine alpha. Okay, now let's compare this to our form. The form that we have is 6 sine x plus 7 cos x. Okay, 6 sine x plus 7 cos x. Now we do have some issues over here, and the issues are going to be, first of all, notice that the first term is actually not going to be the first term over here, because over here the first term has cos x. Here the first term actually has sine x. The second term is sine x. Here the second term is cos x. So in other words, this is going to be the first term. This is going to be the second term. Okay. So since okay, now comparing the terms, we have cos x, therefore r cos alpha is going to be equal to 7. We have sine x, therefore r sine alpha is going to be equal to 6. But we do have an issue, because notice that we have a plus, and this is also a plus because r is positive. We said that r is going to be positive, but over here this is plus, but this is negative. Okay, r sine alpha is positive, that is true. R sine alpha is equal to 6, r sine alpha is equal to 6, but behind the 6 we have a plus. Okay, the 6 is positive, but over here this is negative. So therefore this is definitely not the right choice to be made. Okay, this needs to be plus, and if this needs to be plus, this needs to be a minus. Okay, so the correct form to be used here, okay, so that we get plus on both sides, plus for both the both the terms of the expression. We need plus for both the terms of the expression. Therefore for the cosine in the bracket we need a minus. Okay, so again, it's not important that you need to that you memorize the form exactly, that okay, if I have a plus I need to have a minus. Usually if you try to assume one form and try to expand it and notice that the signs are not working out, in that case just change the sign and start again. Okay, so here you started with plus, we had a minus here, and you notice that this was not working out. So therefore we came back here, changed the sign to minus, rewrote this expression, and you notice that now it is working out, and therefore this is the correct form to be used. Okay, so here you're going to use this form, r of cos of x minus alpha. Now if you use that, r cos alpha is equal to 7, r sin alpha is equal to 6. Okay, and same thing again, r sin alpha by r cos alpha, okay, which is equal to tan alpha is equal to tan alpha is equal to 6 by 7. This time sin alpha by tan alpha, 6 by 7. From there you can find out what alpha is. Rest we have r. Use the same relationship that you used in the previous case. Square both sides, add them up. R square is going to be equal to 6 square plus 7 square. Okay, because r square cos square alpha plus r square sin square alpha is going to be r square. Okay, and from there you can find out what r is. Okay, so find r, find alpha, and then substitute into this expression, and we'll get root of 85 into cos of, this is going to be x minus 40.6 degrees, if I'm correct. Yeah, x minus 40.6 degrees. Okay, so this is your alternative cos expression. Okay, so if you're solving this equation, you could use either of these forms. Okay, it does not matter as long as the question does not specify. Usually the question will be specifying in your P3 examination, but if the question does not specify, you can use the sine of the cos form, does not make a difference, and then try to find r, try to find alpha. Once you find r and alpha, move on to find the solution for the equation. Okay, so let's consider examples for this section. Okay, in this section, the first example we'll be trying to solve is going to be 5 sin theta plus 12 cos theta. Okay, we will be trying to solve this equation. 5 sin theta plus 12 cos theta is equal to 6.5. 5 sin theta plus 12 cos theta is equal to 6.5. We're going to solve this equation. Not only that, okay, part A, solve equation our range is going to be 0 is less than theta, which is less than 2 pi. 0 is less than theta, which is less than 2 pi. Our second equation, our second question is going to be to find the maximum value for this function, and the angle, okay, smallest angle for which this maximum value takes place. And a third question is going to be the minimum and the smallest positive angle, again positive angle, okay, that this minimum takes place for. Okay, so we have 5 sin theta plus 12 cos theta is equivalent to 6.5. We have an equation over here to solve. Okay, now first step, notice that since we cannot simply take cos theta to the other side and divide all sides by cos theta, because this is not 0, this is 6.5. Okay, so we need to combine these two into I'll change the question over here. Okay, in this case, we need to convert this sum of distinct trigonometric ratios into a single sine or cosine ratio. So let's start. Okay, our first expression, let's start with r sine of x plus alpha. Okay, I can use this one, or I could use r cos of x plus alpha. We'll try to use both of this. Okay, both of these are going to be correct. You do not need to use both of them. Okay, as long as you can work out the chosen method, the preferred method that you want to use. Okay, you can use either of them. Okay, as long as you get the answer, that's fine. But usually in the question they will be specifying which form to use. So if they specify the sine form, do use the sine. If they specify the cos form, do use the cos. So r sine of x plus alpha, r cos of x plus alpha. Okay, if you use this formula, in that case let's expand this and let's compare the coefficients. This is going to be r sine x sine alpha plus, r sine x cos alpha plus r cos x sine alpha. Okay, r sine x cos alpha plus r cos x sine alpha. Okay, and this is equal to 5 sin theta minus 12 cos theta. Okay, so the first one you have sine, okay, theta, this was theta, let's replace the variable, it's theta. Okay, so sine theta is with sine theta, and if you compare the coefficient, you have r cos alpha is equal to 5. Okay, so comparing coefficients, r cos alpha is equal to 5. For the second one, you have cos theta, r sine alpha is equal to 12. So r sine alpha is equal to 12. But notice you do have an issue, this is plus, but this is minus. So since this is minus, this is not the correct sign over here. We will be changing the signs. Okay, so now if we start with theta minus alpha, this is going to be minus, and that minus is going to match this minus over here. Okay, so r cos alpha is equal to 5, r sine alpha is equal to 12. Okay, now the rest is going to be solving to find what r is, what alpha is. Divide this by this, you get tan alpha is equal to 12 by 5. Okay, because r cancels, sine alpha by cos alpha is tan alpha. Tan alpha equals 12 by 5. Alpha is therefore equal to the tan inverse of this angle. Okay, use a calculator. We just need one solution, and that also the acute angle. We do not need all the solutions. This one we just need one solution, so that is going to be 67.4 degrees. Okay, for r, okay, if you square both of this, okay, and then add them up, that is going to become r square. R square is equal to 12 square plus 5 square. Okay, again repeating what I said, r square cos square alpha plus r square sin square alpha. That cos square alpha and sin square alpha will add up to become 1, leaving you with just r square. So r square is equal to 12 square plus 5 square on the right hand side, and therefore r is equal to 13. Okay, therefore the overall form, substituting 13 and this one into this one, you get the overall answer is going to be 13 sine of theta minus 67.4 degrees. Okay, so this is what the equivalent for this entire expression. Okay, this is the same as this expression over here. let's move on to this one before you try to continue with the solution. Let's move on to this one. R cos of theta plus alpha equals R cos theta cos alpha plus R sin theta sin alpha. Actually it's minus, excuse me, because we have plus over here, it's minus. For cos, plus in the bracket means a minus in the expansion. This is equal to 5 sin theta minus 12 cos theta. Cos theta is going to be with cos theta, not with sin theta. We'll compare cos theta with cos theta, and we'll compare sin theta with sin theta. Okay, cos theta compares with cos theta, sin theta compares with sin theta. Okay, so we have R cos of alpha. R cos of alpha is equal to 5. Sorry, R cos of alpha is equal to 12. R cos of alpha is equal to 12. R sin of alpha is equal to 5. Okay, R cos of alpha is equal to 12. R sin of alpha is equal to 5. But notice that we do have some sign issues over here. Okay, and the sign issue is for the first one we have plus, but here we have a minus. For the second one we have minus, but here we have a plus. Okay, now in the previous case we just changed the sign over here and the sign over here, and it worked out. But over here, if I simply change this sign and this sign, it is still not going to work out, because okay, let's say that if I do change this to a plus, this plus and this plus will match each other, but this plus is still not going to match this minus. So the best thing to do over here is multiply the entire thing by minus 1. So minus to the entire thing, minus to the entire thing. Okay, multiply both all terms of the expression with minus 1. So minus 1 over here becomes minus, over here this becomes minus R, over here this becomes plus. So now the minus does match the minus and the plus does match the plus. Okay, so this is indeed the correct form. Okay, it was not R cos of theta plus alpha only, it wasn't R cos of theta minus alpha, it was minus R into cos of theta plus alpha. Okay, so usually it's more of a trial and error procedure. Okay, it is possible to memorize the forms, but it's best to just leave it to trial and error, and you can find out the form by just comparing the signs and then adjusting in case the signs do not match. Okay, so we have R cos of alpha is equal to 12, R sin of alpha is equal to 5. Let's continue. Divide this by this, you get tan alpha is equal to 5 by 12. Alpha is equal to, therefore, tan inverse of this angle, and that is going to be equal to 22.6 degrees. And for this one, for R square, okay, R square sin square alpha, R square cos square alpha, add both of them up. Sin square alpha, cos square alpha will add up to become 1, leaving you with just R square, that is equal to 5 square plus 12 square. In other words, R is still 13. Okay, we get the same 13 in both the cases. Okay, the angle is only different. So this overall, okay, put 13 and 22.6 into this, you get the overall expression is minus 13 into cos of theta plus 22.6 degrees. Okay, the plus is from here, the minus over here copies down. Okay, so the angle is still a cube. Okay, so this is our second form. Again, you do not need to use both of them. Okay, you just need to use one as long as you can work it out. Okay, or follow whatever the question says. Okay, so now we have two forms. Let's try to solve both this forms and see whether we get the same answer for both of these equations. For the first equation, you have 13 sine of theta minus 67.4 degrees. 13 sine of theta minus 67.4 degrees is equal to 6.5. For the second one, you get minus 13 into cos of theta plus 22.6 degrees is equal to 6.5. Divide both sides with 13. Okay, this becomes half, this becomes half too. Okay, so we have two equations, just to make sure. I'm just trying to solve both of them at the same time, but they are still two separate equations. Okay, so now we have sine of theta minus 67.4 degrees. I just realized something, that our range was actually given in, the range that I gave was actually in radians, so we do need these angles to be in radians, not in degrees. Okay, it does not matter, the calculation is still going to be correct, it just that the final answer needs to be in degrees, radians. Okay, so let's find the first answer again. Tan inverse of 12 by 5. This is 1.176 radians to 3 dp. Okay, so this is going to be minus 1.176 radians, and this over here is going to be (0.395) radians. So I'll replace this over here, 0.395 radians. So this is 0.395. This over here is going to be 1.176. This is the first equation. So this is the first equation that you're solving. Method 1, this is method 2. Okay. Now continuing, half, sine inverse of half, cos inverse of half. Okay, over here, theta minus 1.176 is equal to sine inverse of half is going to be 30 degrees, which in radians is pi by 6. Okay, cos inverse of half is going to be 60 degrees, which is pi by 3 in radians. Now here we do need to get the other answers, and that depends on the range. For the first equation, we have 0 is less than theta, which is less than 2 pi. Let's write 2 pi down in numbers. So 2 times pi is equal to 6.283. Okay, and we have theta, we need to find the range for theta minus 1.176. So that becomes minus 1.176 is less than theta, which is less than this minus 1.176, and that is equal to 5.107. Okay, now if you use the second method, in that case 0 is less than theta, which is less than 6.283, that is the starting range. But now you need to add 0.395 to this. Okay, and that is going to be 6.678, and over here you have 0.395. Okay, so this is the range for modified, this is theta minus 1.176, and this is theta plus 0.395. Okay, so again, for the first equation, for the first method, the range for theta minus 1.176 is minus 1.176 till 5.107. For the second method, the range for theta is going to be for theta plus 0.395 is going to be from 0.395 to 6.678. Now let's try to solve these equations over here. Okay, we are solving, in this case we are solving sine. So the second solution, okay, for this is going to be pi minus this. Okay, use the ASTC diagram, pi minus this, and that is going to be 5 pi by 6. Okay, 5 pi by 6, and then the rest of the solution is going to be plus minus 2 pi. Okay, if you add 2 pi to this, you'll get 7 pi by 6. No, you'll get not 7 pi by 6, excuse me. You'll get 13 pi by 6. If you add 2 pi by 6 to this one, you'll get 17 pi by 6. but that is definitely going to be out of a range. You can still write it down. Let's write it down. 17 pi by 6. Okay, if you subtract 2 pi from this, you'll get something that is definitely going to be out of range, and subtracting 2 pi from this is also going to be out of a range. Okay, you can still write them down and try to see whether they actually are in the range, but for the timing I'll just continue with the 4 numbers that I have over here. So I have pi by 6, and that is 0.524. And then I have 5 pi by 6, which is going to be actually the other answer is okay. Let's continue with this one. 5 pi by 6 is 2.618. Okay, then you have 13 pi by 6, and that is 6.807, which is out of our range. 17 pi by 6 is therefore obviously going to be out of range. So you get 2 answers, which makes sense because we actually have 1 period. Okay, we have the overall answer was 1 period. Over here you did not multiply by anything, you just added and subtracted. Okay, so therefore our range is still 1 period. Okay, and therefore you should get only 2 answers. Okay, so 0.524, 2.618. Over here you get theta is equal to, okay, before that let's continue this answer, pi by 3. Okay, the second answer is going to be 2 pi minus this answer. Okay, that is going to be if you use your A-stage diagram, you'll notice that this is 2 pi minus this, and that is going to be 5 pi by 3. The rest is going to be add 2 pi and 2 pi to this. 2 pi to the first one is going to give you 7 pi by 3. 2 pi to the second one is going to give you 11 pi by 3. Now let's write this down. Theta plus 0.395. Here this was theta minus 1.176. This is equal to pi by 3 becomes 1.047. 5 pi by 3 becomes 5.236. 7 pi by 3 becomes 7.330, which is out of a range. 11 pi by 3 is obviously thus going to be out of a range. So we have 2 answers over here. Now finally we can easily find out what theta is. Okay, add 1.176 to both sides, we get 1.176 plus 0.524, which is 1.700. For the second one you get 1.176 plus 2.618, we get 3.794. For this one, for the second method, you get theta is equal to 1.047 plus 0.395. 1.047 plus 0.395, and that is 1.442, which is definitely not the correct answer then. And over here, 5.236. Sorry, this is minus 6, excuse me. 1.047 minus, okay, 0.395, and that is 0.652, which is still not correct. Okay, and the other one is 5.236 minus 0.395, which is 4.841, which is still not correct. So let's see where exactly we have made a mistake. Okay, the mistake was over here. We forgot the minus over here. The minus was the mistake. Okay, we forgot to transfer the minus to the other side. So if the minus does go to the other side, okay, in that case these answers need to change. Okay, so these answers are not correct definitely. Okay, minus half, the inverse cosine for minus half is going to be 2 pi by 3, 4 pi by 3, and then the rest are going to be add 2 pi to both of them. So this one is going to be 2 pi by 3 plus 2 pi, which is 8 pi by 3, and this is going to be 10 pi by 3. Now back again over here, 2 pi by 3 is going to be 2 into pi by 3, which is 2.094, and over here we have 4 pi by 3, which is 4 pi by 3 is 4.189, and then if you if you try to calculate 8 pi by 3, notice that 8 pi by 3 is 8.377, which is out of our range. Therefore we just have two answers again as before. Okay, so now we can find out the final values. 2.094 minus 0.395 is going to be 1.700. Okay, and 4.189 minus 0.395, 4.189 minus 0.395 is going to be 3.794. In other words, irrespective of the method you choose, whether you try to use the sine, the cosine, try to solve the sine ratio, the cosine ratio, you're going to end up at the same answer because you're solving the same equation. So you're getting the same answer: 1.700, 3.794, 1.70, 3.794. The answer is in radians. Okay, the answer is in radians, not in degrees, because our question was in radians. Now let's continue. Let's find the maximum value and the minimum value, and in these two questions also we'll continue to solve using both the equations. Okay, so the first one is going to be in the first method we have 13 sine of theta minus 1.176. Okay, so maximum of this expression we're talking about. We're not talking about this equation anymore, we're talking about the expression. Minimum again for the expression you're talking about. Okay, so if we try to rewrite this again in the sine form, for the first method, the sine form, we have 13 sine of theta minus 1.176, and for the second method we have minus 13 into cos of theta plus 0.395. Okay, now the maximum value for sine is going to be 1. Okay, it does not matter whether this is a minus or a plus, or theta, a 2 theta, or 3 theta, or theta plus something else. It doesn't make a difference. In both these cases, sine is going to have maximum value 1, cos is going to have maximum value 1. Okay, therefore in this case sine is going to have maximum value 1, maximum is going to be equal to 13 times 1, which is 13. Minimum is going to be 13 times minus 1, which is minus 13. In this case, cos is maximum 1, but when cos is 1, this is going to be the minimum minus 13 because of the minus over there, and the maximum is going to be when cos is minus 1, and at that point in time the maximum for the entire expression is going to be 13. Overall, irrespective of whether you use the sine or the cos, okay, in both cases the maximum and minimum are going to be the same, 13 and minus 13. Now let's try to find out, okay, the smallest positive angle value for the max over here and the max over here. Okay, if you talk about the max over here, okay, smallest possible angle value when 13 is equal to this expression, when this expression is equal to 13. Okay, let's solve this expression. Sine of theta minus 1.176 is equal to 13. 13 cancels out on both sides. We get sine of theta minus 1.176 is equal to 1. Okay, and then we're going to take the sine inverse on both sides. Sine inverse on both sides will give you sine inverse of 1 is going to give you pi by 2. Pi by 2. The next answer is going to be add 2 pi to this. There's for 1 there's going to be only one solution, okay, because the other solution is pi minus pi by 2, which is 2 pi by 2. So both the solutions are the same in the same period. In one period you're going to have only one solution for sine equals 1. Okay, so this is just a special case. Pi by 2. The next answer is going to be 5 pi by 2, and the previous answer is going to be minus 3 pi by 2. Okay, let's solve the equation. We get theta is equal to add 1.176 to all these answers. We get 1.176 plus 1.176. In the first one you get minus pi by 2 into 3. We have minus 3.536, which is negative. Okay, minus 3.536 is negative, therefore we are not going to consider that. Let's talk about pi by 2. .746, that is the smallest positive value, 2.746, 2.747 actually. And if we use 5 pi by 2, it is 9.030, which is higher than this. So this is the smallest positive value. Okay, so this is the maximum takes place when theta is equal to 2.747 radians. Now let's do the same thing for this one over here. Maximum is 13. This takes place when minus 13 cos of theta plus 0.395 is equal to 13, and that is equal to when cos of theta plus 0.395 is equal to minus 1, and that takes place when theta plus 0.395 is equal to minus 1 takes place when theta is equal to again pi by 2. No, theta is equal to 3 pi by 2, excuse me. Okay, 3 pi by 2, we have minus pi by 2, the previous answer, and the next answer is going to be 7 pi by 2. Okay, and finally add subtract minus 0.395, we get minus 0.395, excuse me, minus 0.395 minus pi by 2, and that is minus 1.966, which is negative. We want the smallest positive angle, so this answer cancels out. Let's talk about 3 pi by 2. We have plus 3, that is we get 3 pi by 2 pi by 2, 3 pi by 2. And the answer says that it is 4.317, and 7 pi by 2 is, if you have 7 pi by 2, that is going to be definitely away. It is 10.6. Okay, now before I try to sort out why this is not matching this, let's try to solve this equation over here. Negative minus 13 is the minimum, when, and the minimum takes place when 13 sine of theta, let me just write this down, 13 sine of theta minus 1.176 is equal to minus 13. Okay, that takes place when sine of theta minus 1.176 is equal to minus 1. Okay, and that takes place when theta minus 1.176 is equal to pi, sorry, not pi, 3 pi by 2. Okay, comma 3 pi by 2. We there you go, that was the mistake that I did over here. This was actually supposed to be pi, this was pi, and yeah, minus 1, the cos inverse for minus 1 is actually pi. Okay, and the previous answer was supposed to be minus pi. The next answer was supposed to be 3 pi, not 3 pi by 2. Now over there, now if you continue to solve the answer, for the answer, you'll get minus pi. This answer is negative, that gets out. You get then plus pi, which is 2.747. The next answer is definitely going to be positive and above. Okay, so this 2.747 does match your 2.747 over here. So notice that in both the cases, irrespective of whether you use sine or cos, your maximum is going to be 13, and they're both taking place when theta is equal to 2.747. The minimum over here, let's try to solve the first one. You get theta minus 1.176, you get 3 pi by 2. Okay, the previous answer is going to be minus pi by 2. The next answer is going to be 7 pi by 2. Okay, now finally theta is therefore equal to 1.176 minus pi by 2. Okay, which is negative. Now we want the smallest positive answer. Therefore, let's continue with the next one. The first answer cancels out. 3 pi by 2. You get 5.888. 5.888. The next answer is definitely going to be positive and higher than this. So this is our answer for this question. Now over here, if we use the minimum over here, minus 13, that is going to take place when minus 13 cos of theta plus 0.395 is equal to minus 13. Minus 13 cancels out. You get cos of the minus also cancels out. You get cos of theta plus 0.395 is equal to 1, and that takes place when theta plus 0.395 is equal to 0. The first answer is 0. Then you add 2 pi to this, you subtract 2 pi to this, you have 3 answers. Now this answer is negative. Okay, if you subtract a negative answer, this answer is going to cancel out. The overall answer is going to be negative. Let's talk about 0. Okay, so 0 minus 0.395, that is still negative, so that answer also cancels out. Now let's talk about 2 pi. When you have 2 pi, the answer you get is theta is equal to 5.888, and that is the first smallest positive number for the minimum of the entire function. So again, in both the cases you get the same answer. Okay, so irrespective of whether you use the first method or the second method, okay, whether you use the sine ratio or the cosine ratio, in each case you get maximum is 13 and theta is equal to 2.747, minimum is minus 13 and theta is equal to 5.888. okay, now again repeating what you learned in this section. In this section you learned that, okay, if you have a complex expression with sine and cos, okay, added or subtracted, okay, so you have something sine theta plus minus something cos theta. In that case you can express that as a single trigonometric ratio, sine of theta plus minus alpha or cos of theta plus minus alpha. Okay, write down this expression, expand it, and then compare coefficients. Once you get these expressions, find tan alpha, find alpha, find r square, find r, substitute back, complete the expression, and then continue solving for your answer.